unit, and in our new unit we're going to be talking about absolute value. So absolute value is a type of equation where you can get more than one solution. So the absolute value of a number x written with these bars, absolute value x is the distance from 0 on the number line. So if I wanted to know the absolute value of 5, how far is 5 from 0 on the number line? 5, right? That's not hard. If I wanted to know how far is negative 5 from 0 on the number line, how far is that? It's also 5. So a lot of people think, oh, absolute value just changes every number to a positive, and that is kind of the effect, but what it's really doing is just telling you how far this number is from 0 on the number line. If I tell you that the absolute value of some number is 5, that means that number is 5 away from 0. And we now know that there are two numbers that are 5 away from 0. What are they? Yeah, very good. Negative 5 and 5. So if you see absolute value of x equals 5, you know that there's two solutions. It could be x equals 5, or it could be x equals negative 5. Two solutions. And then we just show those on the number line by drawing a point at each number. So I'm going to go back to negative 5 and show here's the point. And that one is 5 away from 0. And then over here, here's another point. That one is also 5 away from 0. So for each problem, we're going to solve it, and we're going to also graph our answers. Does anybody have a question before I move on? Okay, make sure you have that. Then we're going to do a problem. All right. I'm actually going to skip ahead to example 2, and then I'm going to have you guys go back to example 1. Notice that I don't just have x inside. I have this whole expression, 1/2 x plus 5. What is inside this absolute value is a distance of 7 away from 0. So this might equal 7, or it might equal negative 7. So we have two different problems to solve here. 1/2 x plus 5, it might be at 7, or 1/2 x plus 5 might be at negative 7. Because if I put a negative 7 in my absolute value, it would turn positive and give me 7. So I'm going to solve both of these, and this is just solving like you would solve a linear equation. For some of you, it's been a while since you've solved a linear equation because you had geometry last year, but the steps are to undo your operations in backwards PEMDAS. So you start by undoing addition and subtraction, and then you undo multiplication and division. So I'm going to subtract first. I'm going to undo the adding with subtracting. Oops, sorry, minus on both sides. So I have 1/2 x equals 2, because I subtracted 5. And then how could I get rid of that 1/2, the fraction? Multiply by what?
2.
By 2. That does work, yeah. Did anybody have a different idea? Because there's other ideas that work too. Divide by 1/2, yeah. So actually, you may want to grab a calculator. Why don't you each grab a calculator for your neighbors? Okay? So I want you to notice that if you multiply by 2, like Ahmed suggested, you get 4. If you divide by 1/2, like Shahir suggested, you also get 4. So they both work. Okay? If you're going to divide by a fraction, put your fraction in parentheses to hold it together. So 2 divided by 1/2, or 2 times 2. Okay, because I'm running low on space, I'm going to do times 2, but you can also do the divided by 1/2 and get the correct answer. Okay, so multiplying by 2 will cancel these out, so I get 1x. So I get x equals 4 for this answer. And then on the other one, I'm going to subtract the 5. I have 1/2 x equals negative 12. Thank you. And I could do the same thing. I could either divide by 1/2, or I could multiply by 2 on both sides, whichever one you prefer. And then I get x equals negative 24, which is not even on this number line, unfortunately. All right, so x equals 4. I'm going to put a dot right here. X equals negative 24. I'm going to show a break in this number line, and I'm just going to make negative 24 right here. And then I've got a dot right here. Okay, so my dot's at 4, and then my dot's at negative 24. Okay. Let's see how you're doing, guys. So you take the expression. You guys asked some really good questions. One of the questions I had was, does that absolute value turn that minus 5 to plus 5? And it doesn't. What we do instead is we take the opposite of the other side of the equation, okay? So we keep everything in the absolute value the same, and then we have 9 and negative 9. That's what changes, okay? So here, we're going to get rid of the minus with what? Undo minus 5 with adding 5. Good. So we're going to add 5 on both sides. And we have 2 times x equals 14. And then how do we undo the multiplication? Division. Now, I think some of you knew that, but you just got confused because of the fraction. The fraction was kind of dealt with differently. And so we get then x equals 7 for this one. And then the steps are going to be the same for the next one. We get a different answer, of course. So this one I'm going to add the 5 again. And this time get 2x equals negative 4. And then divide the 2 and get x equals negative 2. So we have 2 answers, this one and this one. And we're going to mark them on your number line. Negative 2 and 7. Bless you. All right. Number 3 is different. What is different about number 3? Yeah, it starts with a negative number. So let's think about this for a moment. I'm not asking you to do the same thing we just did. I'm asking you to think. If I'm telling you that the absolute value of something is negative 7, what's wrong with that statement? Yeah, the absolute value turns everything positive, right? So there should be no number that will work here. Now, you can do the same steps that we did before. If you do all those same steps, it will shoot out 2 different numbers for you, but then if you substitute them back in, you know they won't work because they won't give you a negative number, okay? So this is where it's really easy to make a mistake. You can subtract 2, divide by 3, get a number out of it, put it on the number line, but it's not right. And you'll know it's not right because if you substitute it back in for x, then it's not going to give you negative 7 as your answer. So this one we're going to write no solutions.
So it starts with a negative, no solution?
If the absolute value is isolated. Sometimes the absolute value is not isolated yet. We'll see some examples on the back. But if you have the absolute value isolated and it equals a negative, then that's going to be no solutions. The absolute value when isolated means by itself cannot equal a negative number. Okay. On the back, we'll see some examples that are a little different. All right, so you guys go ahead now and do example 4. Okay, so 5x minus 2 might equal 8, or might equal negative 8, right? I'm going to add 2. Get 5x equals 10. And then how do I get rid of the times 5? Divide the 5. So I have x equals 2. Then this one. Divide by 5 again. X equals negative 1.2. All right. Can x be a decimal?
Yes.
Yeah, x can be a decimal. Can x be a negative number?
Yeah.
It can. Now, say for example, we're like, I'm not sure if it can. What I'm going to do is I'm going to substitute this negative 1.2 back in for x to see if it gives me 8. And I need to use, I need to find absolute value on my calculator to do that. Did anybody find it yet?
On the what?
It's in the math button. If you
Why would
press
say
math,
eight and not negative eight?
well, I'm going to do both actually. So AB says, why am I checking just one answer? And that's a very good point. I'm going to check both.
Like you said, substitute 1.2 inside of the one that's positive 8. Why would
Oh,
you-
I see what you're saying. What I'm actually going to do is I'm going to substitute back into the original. So the original one you see has positive 8, but it also has an absolute value on it. So I need to go back and find that absolute value now. Okay? So here's what I'm going to do. I'm going to go back to that. Let's see. Where's my... Thank you. Calculator.
Calc.
So I said press the math button. Math button's over here on the left. Then go over to num. See how num is? You have to use your right arrow, and it says ABS. Press enter. You want me to do it again? Okay, ready? Math button. Math is on the left side. It's under the green button. Then use your right arrow to go over to num. And when you want that first choice, ABS. All right, I'm going to do 5 times negative 1.2 minus 2. All right, you see how it gave me 8? So I'm good. Okay. All right, so I'm going to also check the other answer. So I'm going to do the steps again if you want to see these steps. I press the math button. I use the right arrow to go to num, and I press enter to choose ABS. 5 times, I'm checking my answer 2, and then minus 2. Enter. And it also gave me 8, so both answers work. So I checked my answers. I'm going to put negative 1.2. I'll estimate it to be about here, and then I'll put 2.
So every time you get a decimal, you have to do all of it?
All right, so it's a really good question. Do you have to do that every time you have a decimal? No. You want to check your answers to make sure they're not this, extraneous solutions, okay? Now, I happen to know that when I'm solving an equation, I'm only going to get extraneous solutions if I have this situation where the absolute value equals a negative number. So I knew that these answers were going to work. But if you're not sure, if you're like in a situation where you're like, I'm not sure if this is a real solution or an extraneous solution, which means like you did your steps right, but the answer's still wrong. To make sure, you can always substitute them back in for x in the original and see if they work. Okay?
Oh.
So extraneous means you did your steps right, but the solutions still don't work. And so they're not solutions. They're like false solutions. Okay?
Well, so you like,
So this,
plug it in.
yes, you substitute it in. So this might happen when the absolute value of something is equal to a negative number. Okay? So you might get extraneous solutions if you try to solve absolute value equals a negative number, just like in example 3 up here. Now when you're ready, we're going to go to the back and we're going to do some inequalities, which are a little bit more complicated. When we have inequalities, there is a range of answers. The answers aren't just two numbers. It's going to be an entire range of answers. For example, if I tell you that x is greater than 10, you know x could be like 11, 12, 13, or x could even be like 10.111, right? So x would be any number greater than 10. This says the absolute value of x is less than 5. So let's think about that. If the absolute value of x is less than 5, what is a number x could be? X could be 4. Good. X could also be what number?
2. 5.
Negative numbers, but think about it. The absolute value of that number has to be less than 5. So negative what? Negative 1, right? Absolute value of negative 1 is 1, and that is less than 5. So basically, all of the numbers between 5 and negative 5 are solutions to this one. So we have a dot here, and it's connected. Okay? Now, if I tell you the absolute value of x is greater than 5, what are some numbers it could be? It says actually greater than or equal to. So it could be 5, right? And somebody said 10. I heard that. Good. What's another number that's greater than, sorry, absolute value of x is greater than or equal to 5. What else could it be? 7, yep. So it could be all the numbers in between here, right? It could be anything greater than 5 like this. What about negative numbers? The absolute value of a negative number is going to be greater than or equal to 5. What's one number we could use? Negative what? Let's try that one. Let's try negative 4. Negative 4, absolute value will be 4, right? So it's not quite there, but we're getting close. What else could we do? Negative what? Negative 10, yeah. Absolute value of negative 10 is greater than or equal to 5 because it's 10. Also 5, right? Absolute value of negative 5 is 5, and that's equal to 5. So basically all the numbers here. So when you have an inequality, you're going to have a range of numbers. It might be between two numbers, or it might be less than one number or greater than another number. Okay? Notice this one has the word and. I need my, sorry, I'll use this one. This one has the word and. It's between negative 5 and 5. And then this one is going to be or. X is less than or equal to negative 5, or x is greater than or equal to 5. I still have 2x minus 3 is less than 7. Notice that when it starts with a less than, right here, see? It's going to be an and situation, okay? So it's this and 2x minus 3. Instead of less than this time, we're going to have greater than negative 7. Okay, so it's either going to be less than 7 or it's going to be greater than negative 7, and you're going to solve both of those. So we're still going to undo operations. Undo a minus with a plus, undo a multiply with a divide. You will probably get some decimals, and that's okay. Go ahead and solve those two. All right, same steps. Undo the subtract with add. So I'm going to add 3. I have 2 times x is less than 10. And then I'm going to divide by 2. And I get x is less than 5. Yeah, and I'm going to do this one. So I'm going to add 3. I have 2x is greater than negative 4. Divide by 2. And I have x is greater than negative 2. So the way I'm going to put this together is x is bigger than negative 2 and it's less than 5. Notice I have no equal sign this time, so I need an empty dot. So on negative 2 I have an empty dot, and on 5 I have an empty dot. So the numbers that are solutions, they're bigger than -2, and they're less than -5, so they're the numbers in between. So the answers are all the numbers between -2 and 5 with empty dots. The way you put these two statements together is you put x in the middle. X is less than 5. Do you see how this statement is pointing at -2? You're going to make another one pointing at -2 here. This says -2 is less than x, which is less than 5, and it means x is between these two numbers. All right, so I saw a lot of you start by setting this up. Greater than or equal to 8. Or, when you start with a greater, you have an or in between. 3x minus 2 less than or equal to -8. So you're going to solve by adding 2. 3x greater than or equal to 10, and then divide by 3. And we're going to have to estimate we have x greater than or equal to 3.3. Did you guys get that?
Yeah.
Okay, then add the 2 here. 3x is less than or equal to -6. Divide by 3 and get x is less than or equal to -2. Now, because this is an or, we cannot put it together in one statement. So it could be like this. I actually don't usually write it in interval notation, so I'm just going to write it that way. So x is greater than or equal to 3.3, or x is less than or equal to -2. So 3.3 is going to be here-ish. And -2 is over here. Okay, and notice how it's impossible to have a number that is both greater than or equal to 3.3 and less than -2. Like, no numbers are both of those things. So it's either one or the other, not both. All right. In example 5, do you guys see how we have a number outside the absolute value? We have to isolate this absolute value. So we're going to isolate it by getting rid of the 2. How do we get rid of the 2? We're going to divide it, because it's a multiply, so we have to divide. So we start by dividing both sides by 2. And now what I have is absolute value x minus 4 is less than or equal to 5. Okay? So you have to get the absolute value by itself before you can write your two different inequalities. So this one is going to be x minus 4 less than or equal to 5, and x minus 4 greater than or equal to -5. I'll add the 4, and I get x less than or equal to 9, and x greater than or equal to -1. Because it's an and statement, I can put them together.
Oh, shoot. Oh, yeah, I got one. You gotta be fighting babies.
All right. I've decided that things are moving a little bit too slowly here, so we're gonna skip this one, and I'm gonna do this one. I just decided I'm gonna skip this problem. I made a different problem.
It's a whole other problem. It has no relationship.
Brand new problem. Yep, brand new problem. Number 7. I'm doing it instead of doing 6b. Okay. We have to isolate the absolute value first. How do I get rid of a -2? Add, yep. So I'm going to start by adding 2 on both sides.
New question. Is greater than or equal to -6. 8.
All right, do I have the absolute value by itself now?
Yes.
Close. What do I have to get rid of? All right, I have some options for getting rid of the negative. What's one of them? It's a good question. So a really good question is, can you distribute it? If there was parentheses, you would. And I'm so glad somebody brought that up, because this is the most common mistake when you have absolute value. Don't distribute when you have an absolute value. Instead, we're just going to get rid of it. So how could I get rid of a negative? I want it to be positive, right? So I could do a negative times a negative is a positive. Or I could do a negative instead of times. What else could I do? And these are all good ideas. If you multiply or divide negative by negative, you're going to get positive. So you could do times -1 on both sides, or you could just divide by -1 on both sides. Remember that if you have negative, that's the same as -1. So what I'm going to do is I'm going to divide both sides by -1, like that. Does anybody remember from way back? What happens when you divide both sides of an inequality by a negative number? Negative divided by negative is positive, but what happens to my less than? All right, very good. So my less than becomes a greater than, like that. And that happened because I divided by a negative. Divide by negative. Flip the inequality. Now, think back to the beginning. Back at the beginning, I saw that negative number there, and I thought, oh, I wonder if I'm going to have solutions, right? Because I didn't want one side to be negative. But then I got my absolute value by itself, and now this number is positive. So I am going to have solutions. Also, when the inequality is by itself, this is a greater than. So if this is a greater than at this point, it means it's going to be an or kind when you have a greater than. So it's going to be one answer or the other. So I have 5 plus x is greater than or equal to 6, or 5 plus x is less than or equal to -6. And I can solve these just by subtracting the 5. So x is greater than or equal to 1, or x is, subtract, less than or equal to -11.
He sees what he cooks.